This representation describing R2DB, a system for representing and querying weighted semantic web, which is from Arizona State University, will join the effort of Shengyu Huang, Xinsheng Li, Juan Pablo Cedeno, Dr. Camden, and Dr. Sapino. This work is supported by National Science Foundation. Why we need R2DB? First, let we see what's RDF. RDF is the resource description framework which provides a way to express facts about entities and their relationships. RDF includes three triples: subject, predicate, and object, which can encode basic facts. We can see from the following figure that RDF represents data or metadata in the form of a directed graph. Nodes represent entities, and edges represent relationships between pairs of entities. However, existing RDF query language and RDF stores fail to support key primitives needed in a large class of applications, which associate utilities or costs on the available knowledge statement. Therefore, we propose a R2DB system for the weighted RDF graph. In the R2DB system, we made three extensions. First, we add weight to the RDF model, which we call it R2DF model. Secondly, we extend SparkQL query language to support weight RDF query, which we call it SparkRunQL query language. Finally, we propose the AR2Q engine as an extension to the ARQ engine. In the R2DF model, we have a four tuple including subject, predicate, object, and a value between 0 and 1, representing the weight of the triple SPO. The following figure shows that the weighted graph represents integration of two conflicts, Sharpe's taxonomies, and edge value indicates the amount of source disagreement on the corresponding assertion. When we introduce SparkRunQL, first let we see the shortcomings of SparkQL. In SparkQL, weights of the data cannot be used for filtering or ranking query results. Queries do not include reachability predicates that span relationships across multiple edges. Queries return only matches for the named variable. However, in our SparkRunQL, it provides weight filtering and result ranking. Besides that, the n-edges predicate is introduced for reachability analysis. Select add clause is also introduced to help extract entire matching subgraphs for further processing.
SparkRunQL extends SparkQL with calls for weight-aware processing and general path matching. There are 5 paths in SparkQL extension. They are weight extend triple patterns, path query predicates, select add calls, rank calls, soaking calls. Here we will introduce 3 paths. They are path query predicates, select add calls, rank calls. The first step of R2DB system is correcting database. This system can correct 3 indexes, including quadruple index, reachability index, proximity index. From the windows of the system, we could see the 3 index correcting process. Then, this is an example of correcting select at and n-edge calls. With a query like this with parameter select at and n-edge, we will get the returning result like the red picture. The system will return all matching results subgraph in the form of a RDF weight. Then I will introduce the detail of the returning results and query. From the detail query, we could see the query with select at and an edge. Select at outputs the entire subgraph in the form of a RDF graph. Thus, user can explore the resulting graph, including any edges or nodes that have not been enumerated in the query specification. An edge represents all paths start from category clicks. There should be 7 returning results. Here, we just show the top 5 detailed returning results. The first pass from category clicks to wholly safely with the weight 0.01. The second pass is from candle clicks to dusk shark with weight 0.05. The third pass from category to ecclesiasmal branch with weight 0.1. The fourth pass is a combination of 2 passes. The first is from candle clicks to homosophily with weight 0.0099. The second is from holosophily to cameriforms with weight 0.1. So the final combined weight is the sum of the 2 passes, which is 0.11. The 5th pass is from category clicks to ecclesiasmal branch, then to basking shark. The final combined weight should be 0.2. Then we will show the example of rank cross. With parameter rank 3, the system will return the top 3 results. The rank cross takes a parameter, integer k, indicating the desired number of top results based on the results weight. This is the detail of returning results. Conclusion: R2DF is a weight extend RDF model for encoding additional trust or cost information. SparRunQL provides language extensions to the SparQL specification to leverage R2DF. AR2Q provides several operations to support effective processing of SparRunQL queries. That's all. Thank you.